Good morning, everyone. I am Dr. J. Albino Vince, Assistant Professor of Botany, Holy Cross College, Autonomous Nagarkoil, going to present the topic Antimicrobial Resistance, a silent pandemic across life. Why this is silent pandemic? Actually, the World Health Organization consider antimicrobial resistance as silent pandemic because the resistant pathogens spread gradually across the countries, hospitals, animals, agriculture and even environment. Before entering into the topic, we should know about antimicrobials. Antimicrobials, including antibiotics, antifungals, and antiparasitics, are actually magic bullets used to prevent and treat the infectious diseases in humans, animals, and even plants. As we all know, these antibiotics have absolutely been a godsend to mankind. Now, let's see about antimicrobial resistance. Antimicrobial resistance occurs when microorganisms no longer respond to antimicrobial medicine. As a result of drug resistance, antibiotics will become ineffective and infections become difficult or impossible to treat, so that it increases the risk of disease spread, severe illness, disability, and finally even death. Hence, it is an urgent global public threat killing at least 1.27 million people worldwide. Also, it is one of the top 10 global public threat. Now, let's see the mechanistic basis of antimicrobial resistance. Let's see one by one. The first one is enzymatic inactivation. The best example for this is penicillin resistant beta lactam ring. Some bacteria, like Staphylococcus aureus, will produce the enzyme beta lactamase. This enzyme will break the beta lactam ring. When the ring is broken, the penicillin antibiotic will become inactive. Actually, this mechanism is like cutting the blade of the knife before it is used. The next mechanism is target site modification. Here, bacteria will change the structure of target where the antibiotic normally binds. The best example is methicillin resistant Staphylococcus aureus. The methicillin antibiotic normally binds to the penicillin binding site. This methicillin resistant Staphylococcus aureus will modify the penicillin binding site. So, the antibiotics can no longer attach to it properly. Hence, the cell wall synthesis will continue. In simple words, it is like changing the lock of the house so the old key can no longer open the door. The next mechanism is efflux pump mechanism. Here what happens is the bacteria will pump the antibiotics out of their cell using a special transport protein, and this is known as efflux pump. The example is tetracycline resistance. The tetracycline antibiotic enter into the bacterial cell efflux pump will immediately expel the drug. So, the drug concentration becomes very low to kill the bacteria like Escherichia coli. And see, this mechanism is like throwing unwanted guests out of the house immediately. The next mechanism is decreased permeability. Here what happens is bacteria will prevent the antibiotics from entering into the cell, and the bacteria will enter through the porine channels. Some gram-negative bacteria like Pseudomonas aeruginosa will reduce or alter the porins. Hence, only less drug can enter into the host. See, this is like closing the doors and windows so that the enemies cannot enter. The other one is metabolic pathway bypass. According to the name itself, the bacteria can use alternative biochemical pathway to survive. The example is sulfonamide drug. The sulfonamide drug will block folic acid synthesis. The resistant bacteria will obtain the folic acid from the environment instead. So they bypass the blocked pathway. And this mechanism is like when main road is blocked using alternative road. The final one is biofilm formation. The bacteria will form a protective slimy layer known as biofilm. The example is biofilm on catheters and biofilm on implants. The antibiotics cannot easily penetrate into the biofilm. Hence, the bacteria inside will be remain protected. The biofilm can also help the bacteria exchange resistance genes. The example is Pseudomonas aeruginosa. On the whole, this is like bacteria hiding inside a strong food. Coming into the identification of antimicrobial resistance, there are so many methods, but the common one is Kirby-Bayer disk diffusion method. It is the standard method to determine whether antibiotics are effective against a specific pathogen. This method is based on placing different antibiotic impregnated discs on previously inoculated agar with bacterial suspension. So the antibiotic will diffuse radially outward through the agar medium by producing an antibiotic concentration gradient. After incubation for about 22 to 72 hours, the zone diameters are measured in millimeter using ruler. The larger zone is considered as sensitive and smaller zone is considered as resistant. Finally, this result can be compared with Kirby-Bayer chart. As a conclusion, I would like to leave an important message. Stop resistance before resistance stops us. Thank you.